When a soluble salt is placed in water, the salt dissociates into its ions. We can write balanced equations for these processes as long as we recognize what ions the salt will dissociate into. A working knowledge of ionic nomenclature will help here, so review that section if you need a refresher. You'll begin writing any dissociation process by reviewing the salt and determining what ions are present. Our first example includes the potassium cation and the hydroxide anion. These ions are present in a 1-to-1 ratio, which we figure out from the combination of the charges and the subscripts present in the chemical formula. This is actually everything we need to know to write our dissociation equation. This equation will begin with the salt that is being dissolved. Our problem tells us that the salt is aqueous, but you might also see this as a solid with water included as another reactant, or water included as a solvent, which will involve the formula for water written over the reaction arrow. Any of these cases will result in the same set of products. The products of the dissociation are always going to be the ions involved in the salt. Since this salt is aqueous, the ions will dissolve and will also be listed as aqueous. We had already identified the cation and anion as well as the mole ratios, so writing the dissociation equation was just a matter of reorganizing our information. Do be sure to include the charges on the ions in your balanced equation though. Otherwise, it will not be correct. The cation here is the lead-2 cation, and our anion is the nitrate anion. We have one cation for every 2 anions, as given by the stoichiometry of the salt. This means that when we write our balanced dissociation equation, we will have a coefficient of 2 for our nitrate. Again, begin your equation with the soluble salt. We identified lead-2 as the cation based on the fact that there are 2 nitrate ions present, each of which have a -1 charge. Again, you'll need to include the charges on the ions in order for your equation to be correct. When you have more than one of an ion, the subscript that was present in the chemical formula will move from the subscript position to the coefficient position. They are both really 2 versions of saying a similar thing. When discussing the formula unit, I need to use the symbolism and formatting of the chemical formula, thus the subscript. But when I'm talking about the dissociated salt, I'm not really discussing that formula unit anymore. Rather, I'm discussing and symbolizing the pieces that are floating around in solution. Here, the coefficient is the appropriate descriptor of that count. Think of it as saying 2 nitrate anions floating in solution versus nitrate ion 2 floating in solution. The latter doesn't really make as much sense. One last one. The ions here are the sodium cation and the phosphate anion. There are 3 cations to every 1 anion. Start with the sodium phosphate. Then add your solvated ions to your equation. Remember to include the correct charges on your ions and to move the subscript on the sodium found in the formula to the coefficient in the balanced chemical equation.